Welcome to MetaMinds Academy. This is a lecture series on matrices. This is lecture number 7 in the series. The contents in this video are normal form of a matrix and expressing the given matrix A in the form of PAQ. Okay. What is the normal form of a matrix? You are given a matrix, any matrix A of rank R. It can be reduced to this particular form by a sequence of elementary transformations. So what is this form? This is actually identity matrix on the top left corner. You will get an identity matrix on the top left corner. You will get a zero matrix here. You will get another zero matrix and a zero matrix here, like this. Right. So this is IR. This is zero matrix. This is zero matrix, zero matrix. So we simply write it as IR 0, 0, 0. So given any matrix A of rank R, it can be reduced to this form. What is IR? Identity matrix of order R. What is R? R is the rank of A, the given matrix A. If A is a 4 by 4 matrix, A is a 4 by 4 matrix, and rank of A, suppose it is 2, which is R, then you will get I2 0, I2 0, 0, 0. So what is this I2 0, 0, 0? Because R is equal to 2, it is I2. So you will get a identity matrix here, 1, 0, 0, 1, 0, 0, because it is a 4 by 4 matrix. The remaining all will become 0. Because the rank is 2, you will get a identity matrix of order 2 at the top left corner, and you have a 2 by 2 zero matrix, another 2 by 2 zero matrix, another 2 by 2 zero matrix. This is how it will be reduced. So the concept is, in the top left corner you will get identity matrix and all remaining values will be 0. You can use both row and column operations. The important point in here in a normal form, reducing a matrix into normal form is you can use both row and column operations to reduce it to normal form. So let us see problem on this. You are given a matrix of order 4, 4 by 4, right? It need not be a square matrix. It can be a rectangular matrix also. Here in this problem, it is a square matrix. Okay. So our objective is to get a identity matrix at the top left corner. So we have to move non-zero rows to the top and non-zero columns to the left, so that you will get identity matrix at the top left corner. Non-zero rows, non-zero columns to the top and left. Okay. So let us operate some elementary operations on this. Because we have a 1 here in the second row, right? Our objective is, because it is a 4 by 4 matrix, it is a 4 by 4 matrix, except in the first, we use the first row to make remaining all rows 0. These three elements 0, right? So we expect these three elements to be 0. So for that, if you have 1 in the first row, it is more convenient to make these three values 0, right? So that is why you can swap these two rows, right? Swapping these two rows is a better thing. So let us write R1 and R2 are swap. Then how A will be? A will be similar to 1 minus 1 minus 2 minus 4. R2 is 2, 3 minus 1 minus 1. We swapped the first two rows. Okay. 3, 1, 3 minus 2, 6, 3, 0 minus 7. Now we have to make these three entries 0. For that, R2 implies R2 minus 2R1. 2 into R1 is 2. 2 minus 2 is 0. Right? Therefore, our objective is to make it 0. 1. We are not making any changes to first row. So let us write it as it is. And here 0. R2 minus 2R1. This minus 2 into this is 5. This minus 2 into this is minus 1 plus 4, 3. This minus 2 into this, minus 1 plus 8, 7. And here, how to make this entry 0? R3, coming to R3, R3 minus 3R1, because we have 3 here, you multiply this by 3 and subtract. So you will get 0, R3 minus 3R1, 1 minus 3, 1 plus 3, 4, and this becomes 9 and 10. You will get 10 here. And what about R4? R4 implies R4 minus 6R1. 6 minus 6 we need to get here. 6R1, it is 0, 3 minus of minus 6, 3 plus 6, 9, 12, 17. Right. Now I told you you can use both row and column operations, whichever manner or whichever version you want order you can use. Now I make these three entries 0 using column operations, because these three zeros are not going to affect any of these elements. So I use first column to make these three elements 0. So I write C2. I'm not going to make any changes to C1. C2 implies C1 plus C2. C3. So how to make this 0? 2C1 plus C3. 2C1 plus C3. And C4, 4C1 plus C4. So how A is going to become now is, first column there are no changes, 1, 0, 0, 0. Second column, it is adding first column and second column only, 5, 4, 9. Third column, 2 into this plus 2 into C1 plus C3. So it is 0, no changes to these elements, 3, 9, 12. And 0, 4 into this plus 0, 7, 10, 17. 7, 10, 17. So if you carefully observe here, 5 plus 4 is 3, 9, 3 plus 9 is 12, 7 plus 10 is 17. So you can make fourth row as 0. How? R4 minus R2 plus R3. Yes, sir. You add these two rows and subtract from this, you will get 0 here, right? So I move to the next slide. Here it is, R4 implies R4 minus R2 plus R3. So how A is going to become now is, we're not going to make any changes to first row, 0. Second row also, third row also, we're not going to make any changes, 5, 3, 7, and 0, 4, 9, 10. 4, 9, 10, and 0, 9 minus 5 plus 4, 9, 0, 0, 0. So one row is already 0. Now let us make this entry 0, this entry, right? So how it is, R3, I use row operations only, using this row R2. So 5 R3 minus 4 R2. You multiply this by 5, multiply this by 4, you will get, and subtract, you will get 0 here. So A is similar to 1, 0, 0, 0. Second row, there are no changes, 0, 5, 3, 7, 0, 0. So what we have to do is multiply this by 5. This is 45 minus 3 into 4, 12. 45 minus 12, it is 33. Next, multiply this by 5, 50. 50 minus 28, it is 22. So, and this is fourth row is already 0. Right. Now you can divide R3 by 11. Divide R3 by 11. So to make it simple, I am doing it. So A will be similar to 1, 0, 0, 0, 0, 5, 3, 7, 0, 0, 3, 2, 0, 0, 0, 0. Now let us do one thing. R2 implies R2 minus R3. R2 minus R3. In reverse, I am doing it. Okay. Then what happens to A? There is no change in the first row. 1, 0, 0, 0. 0. R2 minus R3. 5 minus 0, 5. 3 minus 3, 0. 5 minus 2. Sorry, 7 minus 2, 5. And 0, 0, 3, 2. 0, 0, 0, 0. Now I can divide R2 by 5 so that A will become 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 3, 2, 0, 0, 0, 0. Right. We need to make these two entries 0. So using column operations we can do. So how to get 0 here? This minus this. It is C4 implies C4 minus C2. So I subtract this minus this. So what happens to A? A is similar to still 1, 0, 0, 0. We need to write column wise. Okay. 1, 0, 0, 0, 0, 1, 0, 0. There is no change in C3, C2 or C3. Okay. 0, 3, 0. So C4 minus C2. So this minus 1 minus 1, 0. 2 minus 0, 2, 0. So we need to get a 0 here also. So it is C4 implies 3C4 minus 2C3. Multiply this by 3 and this by 2 and subtract. So what happens to A? 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 3, 0, no changes to C3, 0, 0, 0, 0. Okay. Now you divide R3 divided by 3. What you will get? A is similar to 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0. So now how it is? This is in the identity matrix form. Okay. So which is equal to, you have I3 and you have a 0 matrix here, 0 matrix of order 3 rows, 1 column. You have a 0 matrix here, 0 matrix of order 1 row, 3 columns. And you have a 0 matrix here, another one, 0, 1 by 1. Right. So the answer is I3, 0, 0, 0. Now the given matrix is reduced to its normal form. And in place of IR, we have I3. Therefore, R is equal to 3, which is rank of the given matrix A. Okay. So this is how you can reduce a given matrix into its normal form and find its rank. Now let us take this topic, another topic. It's a consequence or observation of this. Corresponding to every matrix A of rank R, there exists non-singular matrices P and Q such that PAQ is in the normal form. So here you have A equal to IAI. So how to achieve this? So how to achieve this? You can write the given matrix A as IAI. I is identity matrix. I into A is A. Again A into I is A. So you can write like this. And if A, the order of the matrix is M by N, then this I must be M by M identity matrix. A is a M by N matrix and the right or postfix identity matrix must be of nth order, N by N identity matrix. So whatever row operations we are performing on A, you perform same row operation on prefix identity matrix. Whatever column operations you are performing on this left side A, you perform the same column operation on postfix identity matrix. Then automatically here in place of this, after a finite number of steps, in place of this prefix identity matrix, you will get a matrix which is P. We call it as P, A, and postfix identity matrix will be converted to another non-singular matrix which is Q. So we are able to express the matrix A as PAQ form. But what happens finally is here you will get a normal form IR 0, 0, 0. So after a finite number of elementary transformations, both row and column operations, this matrix A will be reduced to normal form on LHS, and the same row operations on this matrix and this will reduce this identity matrix to P. The same column operations on this matrix and this matrix will make this identity matrix as Q. Here P and Q will be non-singular matrices. Okay. Now let us take a problem and solve. You will better understand. So find non-singular matrices P and Q such that PAQ is in the normal form. Hence find the rank of A. Right. So you are given this matrix A. What we have to do is, first of all, we write A equal to IAI. So IAI. So left hand side matrix A is 1, 1, 2, 1, 2, 3, 0, minus 1, minus 1. And this identity matrix, because it is a 3 by 3 matrix, both the identity matrices will be of order 3 only. So it is 1, 0, 0, 0, 1, 0, 0, 0, 1. Right. Now you need not express this matrix A, simply write it, because we are not going to make any changes on A. So this is also identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Now whatever row operations you perform on this matrix should be performed on this also. Whatever column operations you perform on this matrix should be performed on postfix identity also. Okay. So what is our objective is to make this into, reduce this into normal form. For that we need to get a 0 here and here. It is already 0. So we need to get a 0 here. How to make it 0? R2 implies R2 minus R1. So it is left hand side, we are not going to make any changes to R1 and R3 also. So I write it as it is first of all. Here also no changes to R1 and R3. This A, and here because it is a row operation, it should not be performed on this. So we have to write this as it is. Right. Now R2 minus R1 is 1 minus 1 0, 2 minus 1 3 minus 2. Here 0 minus 1, 1 minus 0, 0 minus 0. Now we have 0 1 1 here, 0 minus 1 minus 1 here. You just add R3 and R2. R3 implies R3 plus R2. What you will get? It is, I write it in the next slide. It is no changes to R1 and R2. Therefore, it is 1 1 2, 0 1 1, and R3 will become 0 0 0, because here we have R3 plus R2, 0 minus 1 plus 1 minus 1 plus 1. Okay. So that will be 0 0 0. Here also there are no changes to R1 and R2. So it is 1 0 0 minus 1 1 0, 1 0 0 minus 1 1 0. No changes to postfix identity. Sorry. here 1. So here what we have done, we added R2 and R3. So what is R2 and R3 here? R2 is this -1 plus 0, -1, 1, 1. So it is -1, 1, 1. Okay. Now one row is already 0. So row is rank cannot be 3, it should be less than 3. That means either it is 1 or 2. You subtract R3 and C3 and C2. Let us perform a column operation. You subtract C3 and C2, C2 from C3. C3 minus C2 is here 1, here 0. You put it in C3, right? It is 1, 0, 0. Whenever it is a column operation, we write columns. 1, 1, 0. This minus 2 minus 1, 1, 0, 0. Right? Next. Here there are no changes to this prefix matrix because it is a column operation. It should be performed on postfix matrix. Here it is, I write it as this 1, 0, 0, minus 1, 1, 0, minus 1, 1, 1. Okay. And here column operation, because it is a column operation, C3 minus C2. So I write 1, 0, 0, 0, 1, 0. C3 minus C2 is 0, 1 minus 0 minus 1, 1 minus 0. Now you can make this entry 0 and this entry also 0 using this particular column. Okay. So C3 and C2. C2 implies C2 minus C1. C3 implies C3 minus C1. So that is how what you will get is 1, 0, 0. C2 implies C2 minus C1. This minus this 0. 1 minus 0, 1. 0 minus 0. 1 minus 1, 0. 0 minus 0, 0 minus 0. Right? So no operations on prefix matrix. So it will be as it is 1, 0, 0, minus 1, 1, 0, minus 1, 1, 1. And postfix matrix, no changes to C1. C2 is C2 minus C1. C2 minus C1, this minus 1. Minus 1, 1, 0. C3 is C3 minus C1. Minus 1, minus 1, 1. So now this is in normal form, right? The left hand side matrix has reduced to I2, 0, 0, 0. So what is I2? This is identity matrix of order 2, 0 matrix of order 1 by 2, 0 matrix of order 2 by 1, and 0 matrix of order 1 by 1 equal to PAQ. PAQ. You need not check. If you want to check, you can check it in the calc. You can find the determinant of P and Q and check whether they are non-singular. Where P is, the matrix P is 1, 0, 0, minus 1, 1, 0, minus 1, 1, 1. You can check it. Its a determinant is non-zero. Q is 1, minus 1, minus 1, 0, 1, minus 1, 0, 0, 1. Right. So P and Q are both are non-singular matrices required. And what is the rank of the given matrix A? It is 2 because you got I2 here. It is 2 are equal to 2. Okay. So this is how you can reduce the left hand side matrix to normal form. Automatically right side you will get the matrices P and Q. Non-singular matrices P and Q. Okay. And that is the end of lecture 7 on matrices. Please like the video if you like it, subscribe to my channel, share it with your friends and classmates. Thank you so much. We'll meet in the next video.